Hello everyone, welcome back to video series on advanced data structure. Today we are going to see AVL trees. First of all, we'll see what is need of AVL tree is consider the input to binary search tree will come in a sorted manner, that is either in a descending manner or ascending manner. Then what will happen is it will draw a skewed tree, either a left skewed tree or right right skewed subtree. So when we are having very sorted ascending or descending order input, we are getting this kind of input. We have seen height balanced binary trees, where the importance of height balanced binary tree is they are faster in searching. So we have to the need of AVL is arise, that there should be a tree where it should be self-balancing one. So AVL is invented by G.M. Adelson, Wesky and E.M. Landis in 1962. This tree is named AVL in honor of this inventors. It is self-balancing binary search tree. AVL tree controls the height of binary search tree by not letting it to be skewed with the help of operations. So this is the example of AVL tree. Whatever the type of binary input for the binary tree is, it will balance itself according to the height criteria by performing some operations to the tree. Now AVL trees operations. The AVL tree can perform the operation insertion and deletion. You can insert the node in the binary subtree without violating property of the AVL tree, that is it should be height balanced one. So the height balance factor should not be more than 1. You can delete a node from the AVL tree with taking precaution that you are always maintaining the height of the AVL tree. Now to maintain height balance factor, AVL performs some operations. These are called as rotations. Okay, so to balance itself, AVL performs many kind of operation. First of all, left operation, right operation, left operation and right operation. Now consider well that these two are left operation and right operation are single performance or single operation, whereas left operation and right operation are double way process, or these are two operation combined. First of all left operation and then right operation. In this case right left operation, first of all right operation and then left operation. So we'll see these operations one by one. First of all, we'll have look at left operation. So when a binary search tree is becoming unbalanced due to node inserted in a left subtree of left subtree, then only LL operation will be performed, that is left operation. We'll see it with the help of example. So here node A is introduced in the left subtree of C, node C. So node C is having a left child as left subtree as a B, and B is again having left subtree as A, which is to be introduced. A new node is to be introduced, will cause a left unbalance factor, and then here we have to perform a right rotation, that is clockwise rotation clockwise rotation will be applied to the edge having balance factor more than 2. So we'll perform this clockwise rotation operation so that B will become a root node and A will remain as it is as a left subtree, and C will be considered as right subtree of root node B. So now from left unbalanced tree we got balanced tree with B as a root node, left operation. So we are converting left unbalanced tree into a balanced tree, making a middle node B as a root node. Now we'll move further to C to look at right operation. So when a binary search tree becomes unbalanced due to node inserted into right subtree of A, then we are performing RR operation. So right of right, new node is to be added. Okay. Now exact opposite to LL operation, it is performing anti-clockwise rotation, which is applied to the node having balance factor -2. So we'll see one example of right operation where a node C is to be added to the right of root node A. So a node is to be added at right of right. Okay. This tree becomes right unbalanced tree with a balance factor as a -2. So we'll perform anti-clockwise rotation where B will take place of A. Now B will become a root node, A will become a left subtree of this B, and C will remain as it is, that is right subtree of node B. So from right unbalanced tree we are performing anti-clockwise operation, making middle node B as a root node and making a root node A as a left subtree of root node B, and hence our tree becomes a balanced one. So this is right operation to make AVL as the balanced one. Now we'll see double operation, that is left right operation. It is required when a BST becomes invalid due to node inserted into a right subtree of left subtree. So it is two-way operation. It is combination of left operation followed by right operation. So in this case we'll see this with the help of one example where we are having a left node is to be inserted, a right node is to be inserted at the left of root node. So this unbalance happens because left right insertion of the node. So a node is added to the left subtree, right side of the left subtree, and hence we will perform the left operation first. Here in this case we have performed the left operation and then right operation to make it as balanced tree. Okay. In this case again what we have done is a leaf node B has become a root node with A as a left subtree and C as a right subtree. Now we'll see right left operation. It is exactly opposite, exactly reverse to the left right operation. So BST becomes unbalanced due to node inserted into left subtree of a right subtree. So again it is combination of two operation, that is right rotation followed by a left rotation. So we'll see it with the help of example. A node is inserted at the left side of right subtree. So a node is inserted at right of left. So it is left right operation. First of all we'll perform left will perform right operation, and then we will be performing left operation to become B, which was the root node, newly inserted node, leaf node to become a root node. A will become a left subtree and C will become a right subtree. Now take your pen and paper. You have to guess operation for this tree. Which operation is required to make it as AVL tree? So you have to calculate height balance factor, and you have to check where the violation of rule AVL property is done. So first of all, check whether height balance is first of all calculate height balance, and then check whether it is property of the AVL is disturbed or not, and if it is disturbed, with the help of what operation it is disturbed, and to become it as AVL tree, what operation you will perform. Consider node 2 is inserted at the as a new node. Here in this case, consider leaf node 2 is to be inserted. Then what should be the operation to be performed? Yes, I think you have got the answer correct. It is LL operation, that is left operation, because node is inserted into left and left subtree of a node, which is causing unbalance to the tree. Now I wanted you to have one more example and guess the operation. So here it is the example, and you have to guess the operation required for this tree. Consider that leaf node 6 is to be added to the previous tree. You have to check whether the imbalance is caused or not. Is there any kind of unbalance, and if it is, what kind of unbalance it is? I think from the previous example it is very easy to find out this. So you won't be taking much time. I think you have all of you have got the answer, and the answer is yes, RR operation, that is leaf node is added to the right of right subtree and causing imbalance to the binary search tree. Thank you for watching this video. Thank you so much.